There were four things we're going to talk about changes in equilibrium. The first one was concentration. That was easy. I've got A, B. I add some A on this side. I take away some C. Whatever. I can predict that. We did that a couple of days talking about that. Then we talked about volume and pressure yesterday. Now we're going to talk about temperature. There are no calculations for temperature. That's good. You'll just have to predict forward or reverse. It's pretty easy. And catalyst, well, you'll see something unique about that too. All right, so let's talk about temperature first. This is really probably the easiest. It's usually do it the opposite way, but the way it worked out is the easiest stuff of this topic is actually last. Changes in temperature. Well, first of all, obviously, it depends on the enthalpy or whether energy is absorbed or released. This is another one of those that's kind of hard to come up with a single statement about. Okay, I did my best to come up with a statement that would cover each of these. But for the most part, it's a lot easier to show you examples of it than there are to actually put it into words. All right? In general, treat the energy like a reactant or a product. You know, if it's absorbing and it's on the left side, treat it like it's a reactant. If I heat it up, it's going to be too much energy. If it's on the right side, treat it like a product. You'll see. So, if I have a temperature increase, well, there's no easy way to put this. It depends. If I increase the temperature, it depends on whether it's absorbing or releasing energy. All right? So the way I worded it was this. It's going to favor the direction that consumes energy. That was the easiest way to just be more generic about it. This will be part of, as I said the other day, the whole first part of the test, first 5 questions or 4 or 5 questions on it, are going to be these kind of questions, where it's just going to say, which way is it going to go? And I'll say adding A or adding B, changing the size of the container, making it smaller or bigger, and I'll say increasing or decreasing the temperature. It's going to consume energy, so you got to figure out where the energy is. When I do an example, I'll show you. Let's just write the notes down first. I'm going to do several examples in a minute, actually. Decrease the temperature. What do you think I'm going to say? It's going to favor the side that what? Yeah, it's going to release energy. Exactly. Favors the direction that produces or releases energy. Makes energy. So you have to, again, use common sense, not try to memorize. This is why, a lot of these things in Chem 1 when we did it, we were doing the same basic concepts in Chem 1 where we had those syringes or jars with water in it, evaporation and condensation. They were tough for you guys, all right, because they're actually really very difficult for a lot of smart students because you guys were used to, give me something to memorize. I want you tell me increase right, decrease left, I can memorize that. But when I got to think about it and it changes and there's a lot of different ways I can give it to you, then it's tougher, okay? And that's why you had trouble with that last time. I don't think you'll have as much trouble now because I mean, you're a little bit older, a little bit more mature, and you've seen it before. All right, let's do some examples. Watch. Say I give you a guy like this. I think it's the easiest way. I can give it to you several ways. Say I give it to you this way. So I think it's the easiest way I can give it to you. And I said to you that I'm going to increase the temperature. I want to see how much room I have there. I want to increase the temperature. Right? Well, this is the easiest way I can write it because I've simply written the energy in as part of the equation. We've seen that before. Energy's on that side. If I read that equation, it says A comes together with B, makes C, and it gives off that much energy. What if I increase the temperature? Which way is it going to go? Forward or reverse? Reverse. It's going to get rid of that energy. It's going to try to do the opposite. Okay, so it's going to favor the reverse.
Do you want to turn that down?
This is my example. Obviously, if I decrease the temperature, it's going to favor the forward. I don't think I need to do a second example of that one. But there's other ways. The reason this can get a little bit hairier is there's other ways I can actually give you the energy in the equation. Okay, for example, I might say this. I tell you the delta H of the reaction is positive 45.9. Now, if I tell you the delta H is a positive value, 45.9, right? You have to think back to thermodynamics. What does a positive delta H mean versus a negative delta H? Positive means what? No. And negative is releasing. Positive is absorbing. See, that does require a little bit of memorization here. You're going to have to remember those conventions. That's just a convention, okay? Positive versus negative. It'll be a little bit easier. Next way I'm going to say this is endo versus exo. If I said exo, you know that, right? What's that going to be? Exothermic is releasing. Endothermic is absorbing. The one that's the hardest is this one here, because it is, you have to remember, positive means endothermic and negative means exothermic. So if I increase the temperature of this guy, and he is endothermic, that 45.9 is actually over on this side, isn't it? Yeah. Remember when we had to do that for the molar energy information equations? So that means it's going to favor the forward. Okay. So that's the hardest one. But the other way I could say it, there's one more way I could say it. I don't know if I have an example of it right here. I think I have another board of examples. Let me see. So we got that one? All right. Oh, yeah, I do have another one. Okay. I just say in the problem, it's an exothermic reaction. So if I just tell you it's exothermic, without even putting an energy in that equation, what side do you know whatever energy it is has to be on? If it's exothermic. No, on the right. Exothermic means energy is, we all know that one. That one's not a convention. That one is common sense. Exit, expel, gives off, release, releases energy. And things release energy when they form them as a product. A comes together with B and releases C and energy. So if he's on this side, I know if again, let's just do it opposite. Let's do the decrease the temperature one. Say I were to decrease the temp on this guy. If I decrease the temperature and I know there's energy over here, what side is going to be favored this time? The forward. It's going to favor the forward because it's going to try to replace that energy. Okay? It's going to favor the forward. Okay, so believe it or not, I know you're waiting for, okay, now it's time to do the long problem. There is no long problem this time. That's the good news. There is no, okay, I add 40 kilojoules of energy. How much further is it going to? I'm not going to do that. We can't do that. All right, we had to do it for volume and pressure. We had to do it for concentration. We're not going to do that. We're just going to ask you which way, forward or reverse. All right. All right, now that brings us to the last one, catalyst. Bless you. Oh, I don't like that color. That's like dull. I gotta change those colors. You can barely read that. Yeah, look at that. I can read it. You can read it perfectly fine. Yeah. Not on the screen over on the TV though. Let's see.
You know you're still on camera, right?
That's better. Actually, I can even use white. Let's use white.
That's
No.
No.
That's too boring.
Can you use pink?
No.
I just used pink. It was too.
You use a crappy
hot
pink.
like fuchsia. Fuchsia.
Down.
No, what
Ew.
are you
Yeah.
Ew, red. No.
Terrible.
Fuchsia.
Go down. No, do that light blue. All the way in the corner. No, up one.
Oh, that's good. That's all right.
That's nice.
All right. Can you read that one? Yeah, that's better. That's better. Okay. All right, we'll use that. Light blue it is. Okay, catalyst. How does a catalyst affect equilibrium? Well, the crazy part about this is you would think that a catalyst would affect equilibrium, but it doesn't actually shift the equilibrium. It does affect it in some way. I'll show you how. I'll talk about how in a second. It doesn't shift it. In other words, it doesn't favor the forward, it favors the reverse. But it does lower the activation energy for both ways equally, and therefore makes it reach equilibrium faster. It will get to equilibrium more quickly. Okay, because it lowers the activation energy both ways by the same amount. You don't have to draw this, but just look here. You've seen this a couple dozen times, I think. But you've seen this kind of a graph before. We know how a catalyst works. He finds a way around that hill, lowers the activation energy somehow. Well, we never really talked about it before, but the fact is, if I have to go this way or if I have to go that way, either way, it's lowered it by the same exact amount. So it really isn't going to shift and favor the forward or favor the reverse, because both of them are going to be easier. All right, both of them are going to be more easier by the same amount. So what happens is you basically get to equilibrium faster, but you didn't really shift it either way. Okay. All right. All right, so you know what? Those last two I told you were the easiest ones. That's it for catalysts. And you saw temperature. Now, I do have a few questions to ask you about it, some problems to do, but they're not going to take you very long. What I really would like to do here, I know you're maybe not all caught up to the same spot, and I want to give you a little bit of time the rest of this period to finish those homework problems, because I want to see what you guys get for. Did anybody finish all the way up through 68?
That's a joke.
Yeah. Tom did?
Well, I did them, but
Well, that's we've been finding. Laura said too. We're not necessarily getting the same answer from the back of the book. I want to see. Believe me, it's very possible the book has the wrong answer. I could not find a mistake in the actual work. But then again, I can't look at every single X, whatever, and see where the mistakes are. So I want to see if enough of you get to that one. We'll see if we all are getting the right answer. We can find where the mistake lies. So you have the rest of this period to do these. All right, that's going to not take you very long. These are just going to be like favor forward, favor reverse kind of things, okay? And then you can also, I want you to keep working on that homework problem because you have quite a bit of time here. Next period, we have the section on your own. I'll talk about that one. So I'd like to get as much done of that as I can, and then maybe compare 68, which seems to be the one we couldn't get the correct answer for completely.
I got the right answer for the first part, but the second part.
Right, that's what we